gathering emphasizes our collective agreement on how important water is at the global level.
A niche conference to position itself among its peers in the overly crowded traditional water shows and conferences we see today around the world.
Meet our existing customers and potential customers and key stakeholders in the Malaysian water market.
This is definitely the show participating in Asia, the big hub for non-urban water solution.
Good afternoon, everyone, and welcome back to the Malaysian Water Association and Malaysia International Water Convention webinar series. And today is our 13th webinar in this series. And we have 3 guest speakers with us today. Mr. Wyeth, who is the Managing Director of Wyeth Water Consultants. He is from UK, but currently based in Thailand. Next, we have Dr. Agustin, Mariscal, Medical Business Director, EAME and Asia Pacific, Kersia Group. And Dr. Agustin is joining us from Spain. Am I right, Agustin? I think, yeah. And we have Mr. Dijk, founder of Eviro-Pure Foundation, Netherlands. And Dijk is currently also based in Thailand. Today, we have the topic, risk and water safety in buildings after lockdown and beyond. And later on, we will be inviting all our attendees to participate in our survey. We have 3 short questions, which we will show later before our Q&A session. And purpose of our survey is to collect some data and feedback from our attendees so that the Malaysian Water Association can use this data to prepare for reports when they make representation to the government or regulators. Attendees, if you have questions for our speakers, you can just key in, you can see the Q&A icon at the bottom of the screen. So just click on Q&A and then you can key in your question. So we're going to start shortly. I'm going to invite Dato Engineer Abdul Kadir bin Mohammadin, President of the Malaysian Water Association, to say a few words before we kick off the session with the first speaker. Dato?
Okay, thank you, Dennis. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Ladies and gentlemen, good afternoon and welcome to today's MWA organized webinar series. And this afternoon is our 13th in the series. And today webinar presentation will look at an interesting topic on the impact of our drinking water quality. That's close to our heart now, this COVID-19 lockdown. The webinar is entitled Risk and Water Safety in Buildings After Lockdown and Beyond 4th August 2020. We can see what happened after this, whether people stay alert after getting all the information from this webinar, because it's very interesting topic that we have overlooked. When we look at water, we have forgot about the reticulation system in our buildings, in fact in the house as well, if we have not used the house for a long time. So instantly, what we are going to learn today is that the coronavirus pandemic might make buildings sick too. Added to this, we will look at much weighty issues, just like food that sits in a refrigerator for too long, water that sits in a building pipes for too long can also make people sick. For this, we would like to welcome the 3 panel speakers, which are Mr. Gary Wyeth from the Wyeth Water Consultants. Mr. Gary is not known, is a very known figure to the Malaysian industry because he's been in Malaysia for quite some time. And we also have this Dr. Agustin Mariscal from Medical Business Director, the EAME and Asia Pacific Kersia Group, Spain. We're honored to have you, Doctor. for this session, because it's very rare that we have a medical business director talking about in our engineering sector. Mr. Dijk van Dijk from Eviro-Pure Foundation, Netherlands, but sits in Thailand. We have close relationship with the Netherlands, and we have yearly round with the dialogue with the Netherlands. And thank you for your contribution on this topic for today. As we are aware, the restrictions placed on businesses and people by the government as a measure to restrict the spread of coronavirus in mid-2020 left many premises having to close down suddenly. As a result, many drinking water systems may have become stagnant over this period, and thus the risk of potential water quality issues. This could have resulted in water in internal plumbing systems warming up, microbiological regrowth, or an increased uptake of plumbing metals. And unless steps are taken before the building is reoccupied, there is a risk of adverse drinking water quality and potential risk health. In normal operation of water utilities, will treat the water at their water treatment plant to a potable level. But then, by then they add chlorine before distributing the water into the pipelines. The level of chlorine is dependent on how far the water must travel, and more importantly, the time taken for it to travel to the farthest point. If water takes 2 days travel to reach the furthest point in the system, then there should be sufficient residual chlorines to ensure after 2 days the water is still being protected. However, the COVID-19 lockdown, we have seen significant drops in customer demands. That means that the time taken for water to travel across the networks has slowed, meaning that chlorine levels may be dangerously low or even go to the zero level at farthest point of the network. In addition, many large customers store water in tanks for reservoirs before distributing it internally within their own distribution system. If chlorine levels were already low, then spending time in a storage tank will further reduce the protection that chlorination provides. Ladies and gentlemen, this webinar will look at the effect that the COVID-19 lockdown has had on the water quality within our water supply scheme systems, and how ultimately affects the end users, specifically the large users that were shut down during the lockdown, such as hotels, universities, schools, offices, and the like. This proposed webinar will involve the 3 speakers. They will speak about 15 minutes. And we have our Mr. Gary Wyeth, who will speak largely on the water quality supply that will involve on how the water utilities ensure our water is safe, and also related to the chlorine usage and what does it mean on the lockdown for this COVID-19 on the demand volume that will affect the residual chlorine levels. And this will be followed by Dr. Agustin, who will speak on the biofilm and the biofilm in water pipes. It's very, very important areas, because this is the source of the matter. And Dr. Mariscal will discuss the challenge of reduction bacterial and viral load, not only in water pipes, but potentially in air pipes and other kind of storage places for water. The third speaker, Mr. Dijk van Dijk, will also speak on the treatment processes to clean and disinfect pipelines. His presentation will focus on methods and technologies to clean and disinfect a protected water system in buildings after a extended period of time with low or zero flow conditions to prevent infection of returning water users. The MWA would like to draw building owners and employers' attention that temporary shutdown or reduced operation of a building and reductions in normal water use can create hazards for returning occupants. 2 potential microbial hazards that should be considered prior to reopening after the period of building inactivity are mold and Legionella, the cause of Legionnaires disease. For mold, a prolonged period may be days, weeks, or even months, but it depends on the building-specific factors, season, and weather variables. For Legionella, a prolonged period may be weeks or months, depending on plumbing-specific factors. Disinfectant residuals, water heater temperature set points, water usage patterns, and pre-existing Legionella colonization. Thus, it is essential that as a matter of procedure and best practice, when buildings reopen following the lifting of COVID-19 restrictions, that any water system is not simply put straight back into use. During the period of shutdown, it should be sensible to formulate a recommissioning plan for each water system to allow safe startup and assurance to users that is safe to be used. Any plan for recommissioning buildings must take into account the safety of the operatives carrying out the work, and it is foreseeable that the hazard present within our water system in this situation would be greater than normally expected, and these shutdown incidents may be repeated in future. We hope that this webinar will bring greater awareness and concern to the building owners, which are likely to be able to access competent help from service providers for advice and recommended actions to be taken to prevent serious health risks when reopening buildings, as shared by our presenters today. Finally, I would like to give a big thank to our 3 presenters for taking their time off, some of it with a different time zone, to share with us today and to share with us on the interesting topic, and also to our webinar host, Protem, for organizing this. And I wish all of us a successful and fruitful webinar. Thank you.
Thank you, Dato'. So without further ado, I will invite Gary to start his presentation. You ready, Gary?
Yes, I'm ready now. I shall just share my screen. For some reason it's gone right to the end. Okay, so thank you everybody for attending today. And as Dato mentioned, I'm going to be talking first of all about water treatment and the supply side of things, which is the disinfection and chlorination of water in the pipes to reduce any risk of bacteria forming or getting to our houses or through our taps from the water supply system. So all water treatment, all water supply companies, they have water treatment plants that they use to treat their water from the raw water supply, whether it's from a dam, from a river, or from a ground source. And the main aim for these water utilities is to make the water safe for humans, and not just from the output of the water treatment plant, but also to make it safe going through the pipes and coming out of the customer's tap. And ultimately, the water companies would hope that it's actually safe for human consumption as well, which would mean that the water coming out of your tap is drinkable, and that would be their ultimate aim. There are lots of criteria that water companies look at when they're looking at raw water sources and that they need to treat them. Probably one of the main ones is physical, which is the turbidity and suspended solids and the color. And they want to get most of those out so that you have a nice, clean, clear water that's coming in. We do have some other chemical and aesthetic criteria, and we would sometimes put in additional treatment processes to remove some of those additional problems. But the other main criteria is actually the biological one. This is the bacteria and algae. And that's another critical factor that the water companies are trying to treat at their water treatment plants. So this is a typical water treatment plant layout. You can see that it comes in 3 stages. You have flocculation on the left, and then you have what we call sedimentation here, and filtration. There are a few different water treatment plant designs, but most of them tend to use flocculation, adding chemicals and flocculation at the beginning. They also tend to use filtration at the end, and it's this sedimentation part in the middle which changes. So sometimes it can be a clarifier, sometimes it can be a DAF system, but basically what we're trying to do is to remove some of the larger particles in your water supply system. But it's actually the disinfection that we're looking at. And this is where we want to get rid of the bacteria. And so at the end of the system, after we've done filtration, we would actually try to disinfect the water to get rid of the bacteria that are naturally in the raw water source. There are a few methods for disinfection. There's chlorine gas, chloramines, ozone, ultraviolet, chlorine dioxide, hypochlorite. So there are various ways that we can do it, but generally chlorine is used in most water supply systems, either as a gas or a solid as a liquid. Generally, it's a gas for a medium to large size water supply company, but the smaller ones would be moved more towards a solid. These require less maintenance and are not so dangerous in terms of handling. Now with disinfection, we actually have to look at it in two different ways. We have to look at primary disinfection. So this is disinfecting the raw water and the bacteria that's in the raw water and getting rid of that initial bacteria. But then having a secondary disinfection, which is where we provide a residual chlorine. So this is additional chlorine that will stay in the water as it flows through the pipes to prevent microbial regrowth. And so when water companies are dosing their chlorine, they're actually looking at it in two different ways. They're looking at the chlorine demand, which is how much chlorine do they need to put in at the initial stage to get rid of the existing bacterial growth in the raw water, but also the free residual chlorine. This is the key one. So this is the residual chlorine that will still be in the water as it leaves the water treatment plant and then moves through the pipe system. I can show it better on this sort of graph here. On the bottom scale, we have the chlorine dose, and then on the side here, we have the chlorine residual. So what happens initially is when we start dosing chlorine into the water, it actually creates chloramines in the water, which these then start to eat away at the bacteria and break down the bacteria that's already existing. And so what will happen is your residual chlorine levels will start to drop off after an initial peak, and then it reaches the break point. This is where we've actually destroyed all of the existing bacteria, and now any additional chlorine that we put into the water actually increases as free chlorine residual. So you may have a water treatment plant which has 2 milligrams per liter of chlorine residual coming out of the plant, but they've actually put in more than that to kill off what was already there in the raw water supply. We can look at it on a sort of like a basic pipe network like we have here. And a lot of water utilities will actually have water quality testing stations. So this is a sampling station that you can see here on the right. And that station, you would have people from the water company would go out and take a sample of water, then they would take it back to their lab and test what the residual chlorine levels are. And these sampling points tend to be at the extremities of the system, because that's where you want to have your minimum chlorine levels. So we're looking at probably a minimum of 0.2 milligrams per liter. And so what they would do is they would then adjust the residual chlorine at the outlet of the treatment plant to make sure that you're achieving that minimum residual chlorine at the end of the system. Now, in Malaysia and a lot of countries across the world, people have started to do what we call district metering, which is where they've started to develop zones. so that they can analyze the non-revenue water and the leakage levels in each individual zone. But to do that, we've had to start isolating valves, closing valves like these three here, which means there's no flow through the pipes. And what can happen is we can actually get stagnant water at the end of these pipes here. So if you do have a length of pipe like this, which comes to a closed valve, and there are no customers towards the end, then flushing is something that becomes a necessity to get rid of that stagnant water, especially after a number of days that it's actually been in there. So the water companies, they're looking to put in their residual chlorine to achieve this minimum residual chlorine at the end of the system. But what can affect that chlorine as it moves through the system? Water age. So chlorine will naturally dissipate as over time as it goes through the system. So one of the things we have to be aware of is how long the water is taking to flow through the network. And this is something that the lockdown from COVID-19 will have affected. So instead of having demands at 100% and water taking maybe 5 days to get to the end, you might have water at 50%. So it's now taking 10 days to get to the end. And of course, the chlorine will be dying off over twice as long a period. Storage tanks. So when we have storage tanks where water flows in, if we're not getting the level of the tank dropping and filling again, you're not actually turning over the water in the tank. And this can mean that you're getting stagnant water in your tanks as well. So it's always best to actually set up your tanks with some sort of level control so that you're getting a flow and rise from them. Limited customers in areas. So normally we look at rural areas, because in rural areas you have limited customers and that's where it's going to get affected. But during the COVID-19 lockdown, we're also looking at, say, industrial areas where we've had factories that have shut down. So now we've got an industrial area which used to have very high flows feeding all of the factories. But now it's got very low flows or sometimes zero flows. And you're going to have a lot of stagnant water in those pipes. Dead ends, like I've already talked about, and also bad pipes. These days, we tend to use a lot of plastic pipes and lined steel pipes, which are not a problem. But if you've got some old cast iron pipes, which are unlined, you're going to get a buildup of corrosion inside the pipes, and those can lead to bacteria as well. Regrowth areas are where you have a system with very high leakage. If you have leakage problems, you can get bacteria coming in through those leaks, which can then start to grow on the inside of the pipe. Water age, as I mentioned, is a key one, and these are some of the sort of typical ages that we look at, where you would expect in a city for the water to be in your system from about 1 to 7 days in length. But if you look at the rural or smaller population areas, it could be 12 to 24 days. And if we're in a lockdown period, that could even extend well over a month to maybe 6 weeks or 8 weeks. So that's something that water utilities have to be aware of, that their water is going to be in the pipes longer. How do we mitigate these? Well, it's reducing the detention time in storage tanks. Maybe we can look at bypassing storage tanks if the flows are very low during these lockdown periods. We need to ensure turning over of distribution systems, and this may mean flushing in some places to get out there and start flushing the mains. How often should we flush? Well, if it's a dead end main, we should really be flushing it every month just to clear that stagnant water. Other parts of the network, maybe twice a year. But what's more important is to listen to customer complaints of bad taste, odor, or even turbidity. And those can be indicators of where your pipes need to be cleaned, and that's where we can go out and start to flush. You can see here a typical system where we've got 1 milligram per liter coming out of the treatment plant, and it goes into an intermediate storage tank. And you can see already the chlorine concentration has dropped from 1 down to 0.7 megaliters per liter because the water has been in the tank for a while. Then it comes down and it can go down branch B here, and you can see it drops to 0.4, but it's still safe. Branch C, it's got 0.5, so it's still safe. But when we look at branch A, where maybe we've got some leakage, we've got unclean pipes, maybe some old cast iron pipes, that is causing the chlorine to have to work harder at the bacteria that's in the pipes. And we're now down to a 0 chlorine concentration. And that's something that the water utility should be checking and being aware of. And then branch D is the low usage area. So if we have a big pipe with low demand, the water can be traveling very slowly, which can then drop the chlorine concentration. And in the COVID-19 lockdown, this is what we're looking at, is areas where we've got pipes, long lengths of pipe with very low flow on them, which are going to have stagnant, almost stagnant water or 0 chlorine residual anyway by the time it gets to the customers. Secondary chlorination is a way that we can get around this. So primary chlorination is where we would add the chlorine at the water treatment plant. But down in the distribution system, we can also, well, there's 2 ways of doing it. The first way is if at the end of the system, the residual chlorine is 0, we can either go back to the primary chlorination and lift it up, so add more chlorine. But of course, if you do that, you're going to then start to get high chlorine levels close to the treatment plant, and you may get customer complaints of taste or smell from the chlorine. If you can't increase the chlorine at the treatment plant, you can keep that the same, but you can add in a secondary chlorination system downstream in your network. And a lot of utilities would do that, where they would have a chlorine pump system that pumps chlorine into their pipes at remote areas. Now, of course, it is possible if you have a user, a large customer, such as a factory industrial unit, a university that has a lot of land, or even a housing development that has a large number of houses or condominiums, they could actually develop their own secondary chlorination system just to make sure that the chlorine is sufficient within their own pipe network. Now, customer tanks are a key, really, because a lot of large customers have water tanks where they can store up to 24 hours demand, or normally it's 24 hours demand. Now, what's going to happen is during the lockdown, we're going to have some places like factories, hotels that have shut down, where the water is going to remain stagnant in these tanks, and also in the pipes that are after the tanks. So once we then start to open up these factories, these hotels, there needs to be a chlorination way to actually empty these tanks, put some new chlorinated water in, and then maybe super chlorinate to just clean the pipes before it goes through. What's probably a bigger problem is when you have hotels that have remained open, or offices that have remained open. And instead of having a water tank that's got a 24-hour supply in here, we've suddenly got a tank which has got maybe 2 weeks or 3 weeks supply, because the hotel's only got 10 or 20 rooms occupied. And that means that the water is actually staying in there a long time, but the hotel or the factory or the office block still think that the water is safe. But because it's being retained such a long time, it could be a problem. So the effect of the lockdown is basically lower customer demands mainly due to the commercial shutdown, which is factories, shops, offices, but also in the hotels as well, which many still aren't open. And the ones that are open have got very low occupancy. This leads to longer lifespan in the water pipes and also in the customer tanks, which then leads to lower residual chlorine levels in the pipe network. Unless you have a very good water utility that's monitoring these chlorine levels constantly and is adjusting the chlorine at the treatment plants. And then, of course, the customer tanks that have got no chlorine residual, which is then flowing into your buildings. And we're then going I think Dr. Agustin's going to be talking next about the buildings and biofilms that could happen in our pipes when you've got zero residual chlorine. And that comes from having stagnant water or water with no chlorine inside it. So thank you very much. That's the end of my presentation.
Thank you, Gary.
Oh.
Yeah, so we will now invite Dr. Agustin to do his presentation. You ready?
Can you hear me?
Yes, we can hear you.
Okay. Okay. So thank you very much for your attendance to the attendees, and thank you very much to the organizers and the Malaysian water associations for the invitation and the organization. Today, during my talk, I would like to discuss the importance of biofilm as a potential big source of most of water problems from microbiology point of view. I will approach these risks and water safety from a medical point of view. And we do believe that if we understand the roots of the problem, we will find better solutions to treat these problems. Basically, I will describe what is the biofilm and how can we deal with it and how can we start decreasing the levels of biofilm. Always from the very important point of safety has to be first and paramount in any medical approach of problems, and also thinking of environment and thinking that environment is where we live, so we have to look after in terms of using parameters and using methods that can avoid big troubles in the environment. Introduction to biofilms would be the first part of the talk, then later protection and stress resistance from the biofilms point of view, and then I will talk about biofilms in water and pipe setting, as well as pipe water quality to finish the presentation. So first of all, what is biofilm? Biofilm is a community of microorganisms that usually they attach to the substrate, which is extracellular polymeric substances, and is similar to a slime layer that many of us we've seen in dirty pipes, and is a combination of bacteria, fungi, algae, yeast, protozoa, etc. It's the most common.
We can't see your PowerPoint. Have you shared screen? We cannot see your PowerPoint.
Sorry about that.
Yes.
So what are you seeing now?
We just see you.
Right. Let me see.
You need to share screen at the bottom.
Yeah, hang on a sec. Apologize. Okay, can you see now? So I missed a couple of
yes
slides. Okay, sorry about that. So where the biofilm grow? The biofilm can grow everywhere. And basically what they do is they find a weak attachment first, they become a strong attachment. The attachment is get into the polysaccharides substrate that I described before. It's a very technical issue, but everybody will understand, and everybody has seen it during any time that you've seen a dirty pipe, or you had to change a pipe, and you see that inside the pipe you can see a lot of different color, as Gary described before, with a bad smell, and usually is where all the germs survive and grow. How do they form? They form from a planktonic, what they call it, planktonic cells, the first cells that they go into the pipe, and then they start growing and secreting different substances like hydrocarbonates, proteins, and fat, and they do the protection of the whole biofilm. So biofilm provides a protective form of growth from environmental stress. So all the antimicrobial agents, ultraviolets, metal toxicity, acidity stress, dehydration, even evasion of immune system is all protected by the biofilm. Let me show you one of the typical example diagram, where you can see that substrate is like a cover of a bubble, where inside you will have aerobic cells, anaerobic cells, and products that they act as a feed for the bacteria, virus, fungi, protozoas, etc. And the oxygen gets inside the bubble, and it will be making this environment survival for the microbiology. Every now and then, the microbiology will break the barrier, and it will move into planktonic cells, as you can see on the right part of the screen. And these cells will go into the water or into the air, etc. Basically, we have persistent cells, and this is a subpopulation of biofilm which can remain viable after treatment with antimicrobial. They are specialized survival cells, and allows quick regrowth of biofilms, making them extremely difficult to eradicate. So biofilm is a big challenge, and it's very interesting to have it in mind every time you are developing a water conduction or water pipe system. There are many kind of actions that you can take, as Gary has been taking, such as flushing before you start a new reopen of a water conduction. In a water pipe setting, which is our topic today, biofilm are everywhere. They contaminate all the water phase by detaching the biofilm organisms from the pipes. So the most important thing is to think about that before we reopen any installation that is being blocked for many hours or for many days or weeks. The biofilms are always related to the occurrence of black water or malodors. We probably not be able to eradicate completely, but the interesting thing is to think about them and take measurements where the conditions of the water distribution has been altered. And that's why in these current circumstances, Gary described very well how many pipes have been closed down, the conditions of the pipes have been altered in terms of chlorination or any other cleaning system that we applied in the past. We are also see biofilms corroding metals, mineral materials, and synthetic polymers. When we think about biofilm and about pipe construction, we have to think about different things like the materials that we are going to use. Nowadays, we realize that some of the plastic materials are a better solution to avoid or to delay the growth of biofilm, and is probably a good substitution of the old copper or metal materials that we were using in the past. Very interesting thing as well is that current studies have told us that the biofilms increase with the flow velocity of the water when the water goes from 0 to 1 meters per second. Later on, when it goes from 2 to 6, the biofilm, the velocity is a protection against the biofilm. So it's very interesting to see that when there is stagnation or there is a very little flow, less than 1 meters per second, the perseverance and the growth of biofilm can be much higher. So rapid changes in water flow, what we'll do is they will break the current biofilm and they will produce the liberation of the planktonic cells, and as explained before in the previous slide. And that will go into the water, and we will need to clean for a period of time that water to make sure that the new water is not bringing bacteria with it. This is an example of how different materials interact with the growth of biofilm, and we can see that copper and steel can promote biofilm formation and growth of Legionella and Pneumophila as well. Copper releases less corrosion byproducts and biomass than mild steel, but potentially the best product is the use of plastic, in particular PVC materials in the pipes, and that's why most of the old pipes are being substituted now. The WHO recommend that the drinking water should be free of any organisms. The water should be disinfected before the date of consumption and also in the plant. And as Gary described it, there is different stages from the time we clean the water in the water plant until it's consumed by the consumer in the house, in the factories, or in different point of consumption. So it's very important that through all these lines, we keep on thinking about the biofilm and thinking about the possibilities of reducing the biofilm. Again, with these new circumstances of the confinement and the lockdown, the problem we have is not particularly the growth of COVID in the water, but more than that is the problem that we can have because of the stagnations, the lack of chlorination or water treatment, and the possibility of having a bigger growth of biofilm and other potential dangerous microbacteria. So we already discussed the influence of biofilm can do in the taste and odor of the water, and also on the corrosion of the pipes, and also the release of ion particles into the water in case of the metal pipes. So the challenges that we have is what is a realistic biofilm or understanding of how much biofilm can we afford to have in a pipe. Every biofilm is different and has multi-species. What are the most important species for water treatment? How can a robust biofilm be consistent and reproduce? And the problem is that we don't have a huge guidelines available for general biofilm kill claim. So still is a big topic. The interesting thing is that we are already discovering different substances and different approaches that can help us to control the biofilm and to avoid massive biofilm and subsequent planktonic cells liberation into the water. How can biofilms be targeted? Biofilms more accurately represent the occurrence of microbes in the real world environment. Free living cells remain the model for testing. Currently, as I said, there is no standard to evaluate efficacy of disinfectants against healthcare-associated biofilms and water treatment biofilms. Nowadays, we are particularly interested in some of the work we are doing with the Environmental Protection Agency in the United States to produce guidelines in terms of dealing with the biofilm. And we have some potential products and some opportunities of projects where we are testing biofilms attack and products to preserve the long-lasting effect of the substance that we can add to the water, always being environmentally protective and always thinking about safety for the consumer as well. We always think about the safe water is a consequence of a safe world, and if we think that biofilm is probably the root of the microbiology problems in the water, we need to start investigating and dealing more efficiently against the biofilm. Thank you very much for your attention. And this is the end of the presentation.
Thank you so much, Dr. Agustin. So now I will invite Dijk, Mr. Dijk van Dijk, to present his start presentation. Dijk, you can on your video so we can see you.
Let me see.
Yes.
Yeah, I see my camera is out.
Okay.
Yeah, there we are. You see my handsome face now?
Yes, yes, we can.
Okay.
You can start.
All right. Thank you very much. Gary and Agustin, you make my life a lot easier. You explained a lot about the water distribution, the issues, and also the biofilms. I'm concentrating more on the methods to prepare the systems after lockdown. Let me see if I can, there we go. We know now that under low or no flow conditions, we have a lot of growth, and particularly here in the warm climates, it is even much more important than it is in the moderate climates. The tap water systems are really breeding places. And as we have seen, the chlorine residual, as supplied by the water treatment plant, can disappear rapidly, particularly in no flow conditions. Where do we find all this growth in buildings? Well, storage tanks, rooftop tanks, underground tanks, whatever storage facilities there are. The pipelines, but also in drains, toilets, shower heads, and aerators. Maybe you don't realize that, but if you remove an aerator from a tap in your kitchen or in your wash basin, it is awful what you see on that little sieve. It's a breeding place. Nobody ever cleans them, but they are a source of bacteria. But there's also ice makers, you know, in office buildings, in hotels, water coolers, fountains and water displays in hotels, for instance, whirlpools and spas. That's everybody probably knows about that. But even in air ducts, you can have growth. Now, how are we going to prepare a building after COVID? In the first place, you have to rinse all these systems, flush them for a minimum of 10 minutes at full flow, whatever you can manage. Then preferably the hot water lines must be circulated with hot water at approximately 60 degrees C, or shock chlorination. And then another thing that very, very few people think about, refill the floor drains, because all the water in the water logs will have evaporated. So there is an open connection with the sewage system. Now, flushing with hot water is very difficult. The water heaters may not have enough capacity to do that system, you know, continuously over a period of time, opening all the taps in a building, particularly like in a hotel. The individual flow-through heaters, as we use in Asia a lot, they don't have the capacity to do that. So hot water flushing is probably not the best way to do it. Also, dead ends in pipes, even 30 centimeters, will not get to the temperature that you want. Cold water, you can't rinse them with the hot water. You can't cross these lines. Then toilet flush tanks have been sitting there for weeks. Bum washers, they will be infected. And if you want to do a good job, you should do this treatment every 3 to 6 months. Nobody does it. So we have a number of methods available. Chlorination is one, using bleaching powder that you dissolve in water. You have sodium hypochlorite that you can buy in canisters or tanks, or even have a tank truck coming with 3,000 or 5,000 liters, depending on the size of your building. There is gas chlorine that comes in pressurized cylinders. There's chlorine dioxide, and there is sodium dichloroisocyanuric acid. Sorry, that's a mouthful. And there is trichloroisocyanuric acid. These are products that are used a lot nowadays. The bleaching powder, the chlorine and the gas chlorine are quite unstable, especially in hot climates. The first two will lose their strength quite rapidly in storage. Gas chlorine, of course, is used directly from the cylinder through a special unit. But it is a very dangerous product. You have to have good, well-trained staff to handle that. Chlorine dioxide is quite stable. And then the both isocyanuric acids are also, they are actually very stable. The isocyanuric acids are supplied as granulates or tablets. The moment they come in contact with water, they will form hydrochlorous acid, or HOCl, which is the most potent chlorine product. In dry form, they can be stored for 3 years. They typically come in pails, in buckets with a lid, or in a cartridge, and they won't lose their strength. They will be 100% even after 3 years if you open them. These products have been used many, many years in swimming pools, but they have never been used for drinking water until 2001, when some brands were approved for drinking water by the EPA in the US. One top brand of trichloroisocyanuric acid is produced under pharmaceutical protocols and is halal certified. And these products are typically tested and recommended by WHO, UNICEF, NSF, and others. Then there's a second method to do it, with ultraviolet light. I've been doing that since 1976. Ultraviolet started already 110 years ago in the city of Nice in France, where they built the first water treatment plant with UV disinfection. Unfortunately, the First World War started and the bulk production of chlorine started. And ultraviolet disinfection was put aside a little bit. After World War II, when the fluorescent lamp, the tubular lamps were developed, which are UV lamps, then UV became popular again. Fluorescent lamps are UV lamps. They just give visible light because the inside of the lamps are covered with a coating. Now, UV is the leading disinfector for drinking water and wastewater in the world. It's very effective to destroy microorganisms, but it does not have a residual effect. What is in the pipes stays there. And unfortunately, systems available in do-it-yourself stores or online, available online, are all under-designed, they are delivering less than half the dose what is recommended for the industry, but that makes them cheap. Then there's a third application, that's ultrafiltration. Ultrafiltration is a real mechanical removal of all micropollutants. UF is a brother or sister of reverse osmosis, RO. It's a membrane filtration, and most of the time the membrane material is made of a polymer like PVDF or PAN, which is a polyvinyl acryl nitrile, or polysulfone. It depends on the applications. There's also ceramic now. They are ideal for point of entry in buildings. Once the water has passed all these pipelines, picked up all kind of dirt from biofilms, etc., they will remove it before the water comes into the building. Unfortunately, it doesn't have a residual, just as ultraviolet, but since you have removed basically everything, in many cases you don't even need a residual if the distribution system is not too long. But always leave it to professionals if you install systems like this. Then there is a very old method that is sulfur contacting. That has been around for more than 2,000 years. In India, the Roman Empire, they didn't know why, but they knew that when they were eating from silver plates and drinking from silver gauntlets, they wouldn't get sick. And in a lesser effect, copper did the same thing. Silver is very active. It's more active than copper, and it can be dosed as attached to a powder in tablets and bonded to activated carbon. Or about 30 years ago, it was very popular in the shipping industry, where they would disinfect the water on board ships by adding silver through electrolysis. Now they combine it sometimes with copper for LJ control in pools. And of course, copper is a lot cheaper. It used to be quite popular until UV came on the market in a big way. And now it's mainly used in swimming pools. Then the last one is ozone. Ozone is a very unstable product. It always wants to shed that one O atom. So it has to be produced on site. Typically, they do it by the discharge of high voltage between 5,000 and 10,000 volts in oxygen-rich air, and then it's mixed in the water stream. It is a very potent oxidizer, and it reacts with everything, which means also with metals. So metal pipes and ozone don't like each other too much. And so any residual that may be left over is gone very quickly if you do this job with ozone. There's one negative aspect. If water is produced from seawater, drinking water is produced from seawater by reverse osmosis or evaporation, vacuum distillation, the combination can form bromides. And just as gas chlorine, it's an extremely dangerous product. You really need professionals to handle it. So what we do in ASEAN. Now, after we have seen what can happen, Gary and Agustin have told you. I think chlorination at this moment is the best method to do because of its residual effect. Ideally, a combination of ultrafiltration and one of the isocyanuric acids would be used. But post-COVID, to get these buildings started up again, I should recommend to start with simple dosing systems that are easy to handle, no dangerous chemicals to store, and with stable products. And these are available. Then chlorination, in a building post-COVID. And should be done with about 2 to 5 ppm free chlorine to start with, measured at the farthest point from where you inject the chlorine. Then let it sit for about an hour. That will make sure that the chlorine can react with all the organics in the system. After that, you flush with fresh water that has a lower chlorine dose, 0.2 to 0.5, until you measure that again at the end of the system, including the toilet bowls. Don't forget. And then maintain this level during the use of the water. Now we were talking about water, but air conditioners also use water. Central air conditioners. You have humidifiers and you have cooling towers. Humidifiers are very dangerous things. I had an experience with them already 30 years ago, more than 30 years ago, in a large office building in Belgium, where they had what we were calling a sick building syndrome. And everybody got sick, after a couple of days. They claimed that it was because of the office landscapes that were very in fashion at the time, and windows couldn't be opened. But eventually they found that it came from the humidifiers of the aircon systems, where you have water being pumped around and sprayed in the air to bring more humidity in the air that was dried because of the cooling effect. And because this water was pumped around and dripped down in a tank, it took up all the spores from the air, and it was circulating as soup. I installed a small UV system in it in the loop, and within a couple of days there were no more sick building syndrome complaints. The same goes for cooling towers. Cooling towers are breeding places for particularly Legionella bacteria. The cooling tower also circulates water and evaporates it. And it is an ideal environment for these bacteria. And because of the strong air passing through these towers, let's say the cloud that comes out of the tower with all these droplets, all these aerosols, spreads in the area. That could be close to an intake for the next building. Or the aerosols after 500 meters or even a couple of kilometers could come down and infect other people or other buildings. Again, 20 years ago, I had an issue in France on a nuclear power plant where a brand new nuclear power plant that the government threatened to close because the plant was infecting a valley where people were recreating. It was river water passed through the cooling towers, and then this plume of aerosols was drifting through the valley and infecting everything that it could find. We installed a very large UV system, 1 cubic meter per second flow, and with a very high dose because Legionella is quite resistant, and we solved the problem. So please make sure that your cooling towers also have some sort of disinfection. Air ducts are quite simple. You just put a UV lamp in and anything will be solved there. There's also a possibility in smaller cooling towers where you do a combination of sand filtration with the UV and circulate part of that contents over the system and keep the water in good condition. Or instead of sand filtration, you use ultrafiltration and a small chlorine disinfection, and that will save up to 80% in the formulated treatment chemicals, which is the major cost of running an air conditioning system. And you have the same effect. next to that, you save a lot of water because you don't have to purge so much. Because if you add all these chemicals every day, you get an increase of your conductivity. Your dissolved solids will go through the roof, and you have to dump about 10% of that water regularly. So that would be a very practical approach in aircon systems. And again, the air ducts can be kept clean quite easily. So as a conclusion, make sure that all the buildings are treated before you let people in. The maintenance people have to be extra careful not to get infected by Legionella. As said, I don't think in these buildings that are opened, coronavirus is a problem, because if there are no people, there's probably also no coronavirus. And follow the guidelines by WHO, CDC, etc., of preparing those buildings. And if you apply a technology, use a professional, not your around the corner plumber. And during the normal operation, check free chlorine in your water system. Thank you very much.
Thank you very much, Dave. And so we have a little, we're going to play a little video. Oh, we have a poll now. Okay. All right, attendees, we have 3 questions, 3 short questions. You can scroll down to see number 3. Can you fill in these 3 questions for MWA? Here you can see slides of the technology that Gary, Dijk, and Dr. Agustin is talking about. Okay, so our results are out. So you can view the results by scrolling down as well. Okay, thank you so much, Henry. So Henry, you'll be showing us the video. Okay. Our speakers can review some of the questions in the Q&A. We have questions are coming in, so our speakers can have to take a look. Okay, so we will start our Q&A session. Can invite Gary. Gary, maybe you can review the questions and can let your partners know who should be answering them.
Yeah, sure, no problem. Dijk and Agustin, if you want to come back online.
Yeah.
So we have one question, which is, we understand COVID-19 is spread by inhaling, not drinking water, as propagated by authorities in the current pandemic. How then we put blame on health issues by drinking water in buildings to cause COVID-19? I think it's more of heavy metals and other chemicals due to stagnant water in storage and plumbing systems, not disinfection as advocated in building reopening. So I think,
can you press the button, Gary? Can you press the button answer live so everybody can see the question?
Okay. So I think really, I think what we're not saying that COVID-19 is spread through the water supply. It's actually the lockdown during this pandemic which has caused differences to the water supply systems. Is that true, Dr. Agustin?
Yeah, so the reason we started talking about biofilm and the reason we introduced that topic is that, as we said, the stagnation and the lockdown is promoting the regrowth of something that is in there. And because it hasn't been treated, the problem is not necessarily the COVID-19, it's the consequence of the lockdown of the buildings.
Yeah. So, I mean, I'm not sure who asked that question, but I hope we answered it during our presentations.
So there is another topic that mentioned that is the heavy metals. The heavy metals, if there is a stagnation, it should be the one it is, and perhaps depending on the pipes, I already mentioned during the presentation, if it's iron pipes, you might have some extra materials like lead. If it's lead pipes as well, or copper, you can have dissolved during that process of stagnation. But I think the heavy metals we could get rid of, as Dijk mentioned, flushing for a period of time, maybe 1 hour during the reopening. So, but the main problem is the regrowth of the biofilm and all the microbiology that is going to be built inside. So we need to be aware of probably a shock treatment the day we open the building, etc., and a good flushing system as well.
Okay. We have a question from Philippe, which is regarding flow velocity versus biofilm. Greater than 1 meter per second that you mentioned, Dr. Agustin. It says, is it based on laboratory tests or on real case studies?
Well, it's been based on many laboratory tests. The real case study is more based on experience. When we have been designing different systems, to be honest, you have peaks, up and downs of the water flow. Is very difficult in a complicated pipe system to maintain a regular water flow. But we found like 1 liter per second, and it's also very much in accordance with the laboratory studies. There is a worse situation in terms of the biofilm growth when you increase velocity, and it gets also a limit like around 6 liters per second that in the velocity, that also gets more difficult to control the biofilm as well. So, but it's based on the 1 liter per second is true, it's based on studies, but we also kind of a check in the experience that the having in between 1 to 6 is a good water flow to keep the biofilm down.
Okay, so we have another question, which is the looping of pipes at the furthest area effective to manage the residual chlorine problems? I think it helps because you obviously don't have stagnant water, but you still need to have water flowing and also enough residual chlorine from your treatment plant as well. But by looping the water around, yes, it will help, but there's still some other factors that you need to look at. Okay, we have a few questions from Denny. First one is, where did the sampling test should be placed? Because in Surabaya, we do the water quality sampling test from the customer's tap, and most of the free chlorine in customers' taps are less than 0.2 milligrams per litre. I mean, I think taking it from the customer's tap is okay, as long as the customer tap is direct with the water main and hasn't gone through a storage tank first. If it goes into a storage tank and it sits there for some time, you're going to get the residual chlorine dropping off. But I know, like in Malaysia, you have a kitchen tap, and the kitchen tap tends to be direct to the water supply. And if you do the sample from there, you're going to get true chlorine from the mains. Question 2. Our piping line is interconnected, and we applied secondary chlorination by injecting 1 milligram per litre of chlorine gas in our distribution tank, but it disappears rapidly. I don't know if you could answer that one, Dijk, if it's something they're doing there.
Well, if this is a typical problem with chlorine in a distribution tank. You know, if the water is staying there for a longer period, the chlorine will disappear. So it would be better, I hope you agree with me, Agustin, to do the chlorination after the distribution tank in a controlled way. And that could be a very simple system, so that you have a constant disinfection the moment the water taps are opened downstream.
Yeah, I think you mentioned that, Dijk, just to add on your presentation, but you made it quite clear that the long-lasting effect is very important, and perhaps with the gas, the long-lasting effect is very short. We are talking of just a couple of hours, as opposed to other kind of methods where you can increase up to 3 days.
Yeah, correct. And that would be the case with hydrochlorous acid, for instance.
So the third question is there any procedure applied in Malaysia to maintain the water quality is still safe even after the pipe breaks, repairs? I mean, this is something which should be done, and a lot of Western countries do it. So when they have a pipe break or a repair of a pipe, they will actually flush the main and chlorinate it as well to clean those pipes. I've never seen that done in Malaysia, so maybe there's someone there that can claim they are doing it, but I don't think it's done at the moment. I think people just rely on the residual chlorine to continue cleaning afterwards. Can we calculate how long the water age should be stayed in the distribution lines? I don't know if there's an easy answer for that, Dijk, is there, on with chlorine levels and how long it would last?
Yeah.
Agustin, I think that's something you can answer as well, but I can try to give an answer. If it's the typical chlorination, within 1 or 2 days, the chlorine is gone. If you use the hypochlorous acid, it will maybe last up to 6-7 days.
Yeah, I would agree with you that it's difficult to do a direct measurement, but perhaps considering that the water is alive is when we have small numbers of ppm still in the water, meaning that you have a nice color, no odor, you know, like a typical very clean water. But you know, depends of the levels of the pipes, depends of the distance, depends of the amount, depends of the original chlorination levels. But generally speaking, I think you answered very, very, very nicely, Dijk. Perhaps 1-2 days with typical chlorination, with a long-lasting chlorination, hypochlorous acid methodology, probably up to a week.
Okay, so the next question is, what is the best disinfectant agent applied for secondary chlorination, which is located in the center of the settlement? I think she means downstream in the network.
Well, basically, it's the answer we gave for number 4 already. Hypochlorous acid.
Right. And that's injected into the pipeline is the best way, yeah?
Yeah, yeah. So a small unit at the center of the settlement in the village where they had the storage tank, that should do it.
Right, okay. And probably number 6 is a similar answer. How to apply shock chlorination?
Just dump a lot of chlorine in it.
So I suppose shock chlorination just means a high concentration of chlorination,
yes,
is it?
Correct.
Yeah, so what we're saying is you use the same methods that we just talked about, but you put a higher dose in just for a short period to do a shock of chlorine through the system.
Yeah,
it should be, just to clarify, it should be flush.
Yes, yeah.
You know, I mean, I think everybody understands, but we have to avoid any drinking water or using that water for any during a period of time.
Yes, so we're putting in a high concentration, but it needs to be flushed out well before anybody can drink the water or use the water. Yeah.
Correct. Yeah.
Okay, and number 7 is, does Malaysia also apply air scouring to clean their pipelines? So there are some utilities that do air scouring. I know in Johor Bahru in the south of Malaysia, they do air scouring to clean their pipes. This probably cleans out, what it's trying to clean more is sediments that have settled in the bottom of the pipe, not necessarily the biofilms. I'm not sure if air scouring would clean biofilms. Would you know about that, Dr. Agustin?
No, I'm not very familiar with that.
So air scouring is where you pump air into the pipe in sort of like bursts, and what it does is it just mixes up the water and air, and it picks up the sediments in the bottom of the pipe. So,
well, if it's only air, it's difficult because you usually need to erode or to get rid of the biofilm. You need an oxidizing agent, but also scrubbing, so you can scrub with the force of the air. But you need an oxidizing agent. Without a low pH, it's very difficult to detach the biofilm from the pipe.
Yeah. So to answer the question, I mean, air scouring is done in Malaysia, but it's more to reduce the sediments in the bottom and reduce possibility of turbidity, but not necessarily to clean the bacteria.
Yeah.
Okay, we have another question. Where is the chlorine gas injection point? I think this is at a treatment plant. Is it near the distribution pumps or at the reservoir inlet?
I would say at the reservoir inlet. So you protect the water while it's in the reservoir.
Yes, I agree. It's between the filters and the storage tank before it gets pumped.
Correct. Yeah, correct.
I mean, generally, the storage tanks at treatment plants, the water is not stored there for very long because the treatment plant is treating continuously. The water is being pumped out continuously. So you don't have too many problems of the chlorine residual fading away there. Which country, especially in ASEAN, that have such water rules for protecting water quality in buildings, including regular cleaning? We don't have it in Malaysia, maybe at cost. So maybe you know, Dijk, is there any regulations for cleaning?
I haven't seen any. I'm surprised, but I haven't seen any.
Even in Singapore or?
Singapore, maybe. I'm not familiar with Singapore, but the rest of the ASEAN, I haven't seen any regulations on that part.
Right.
They say you must have 0.2 minimum, but there is, who's testing?
Yeah.
And
Okay.
cleaning the pipes in buildings, nobody does it.
Right. Okay. So we have one other question, which is the monochloramine still reliable for disinfection, especially at the furthest area?
Question for Agustin.
Well, apparently you have less concentration of a percentage of HClO with the monochloramine. There are also some controversial with the chloramines productions as well. I'm not sure in Malaysia what is the situation. In most of the European countries, it's been substituted by hypochlorous acid derivatives from calcium hypochlorite or sodium dichloroisocyanurate or dichlorisocyanurate. I know it's still used in Vietnam, but there was some controversials with some intoxication problems.
Okay. And we have one last question at the moment, which is, how do you perform chlorine demand in the distribution system? I'm guessing what you mean is, how do you
measure?
How do you calculate how much chlorine to put in at the treatment plant? I'm guessing. And I mean, there's no fixed answer for that, because every water supply system is different, depending on how big the system is, the size of the pipes, the demands in the pipes, the pipe materials, the flow rates.
The age of the pipe.
The age of the pipe, yeah. How many leaks you have. So there's so many different things that can affect the degrading of the residual chlorine going through the system, that you actually have to do water quality sampling. So you have to have sampling points at the extremities of your network to figure out what is the chlorine residual levels, and then you have to adjust your treatment plant free chlorine at the treatment plant so that you're getting enough residual at the end. So it's a bit of trial and error when you're first setting up your system to make sure that you're getting enough residual chlorine at the end. Anyone else want to add to that, or no?
Oh, I think you're right. I think I agree with you.
One other question is, when using chlorine dioxide is used to flush biofilms, usually how long will it take, and what is the usual dosing?
Can you answer that, Agustin?
Well, I know that they use it. I don't know exactly the length of that, but I know that they do around 30 minutes, something like that. But I'm not fully convinced of I'm not an expert on chlorine dioxide.
Me neither.
I know that they use it. I know that they do the flushing, and there is a controversial because of the price. So sometimes they should use it for longer, but chlorine dioxide is one of the most expensive biocide that you can use for this flushing. So I believe that they do systems of 30 minutes, something like that.
Okay, and the last question is it advisable to do post-chlorination at the finished water reservoir? So I assume this is at the in the water treatment plant. You mean the reservoir after the filters? And so probably the answer is, I would say yes. You chlorinate just as it goes into the reservoir, and then it's going to actually help to mix it as well from the chlorine that's going in, and it's going to ensure that your reservoir is clean as well.
Yeah, I agree.
Yeah. Okay. Any other questions from anyone before we finish?
I think there are no more questions, Kim.
Okay.
Yeah. So thank you, everyone. First of all, I'd like to thank Gary, Dr. Agustin, and Dijk for presenting today. Dr. Agustin, you woke up very early, joining us from Spain.
No problem. It was a pleasure. It's okay.
Yeah. How is the weather in Spain now? I hope it's very nice.
Yeah, we have a good summer here, so yeah, still good weather. Yeah.
Thank you. So many thanks to the Malaysian Water Association for our host today, for hosting today's webinar, and thanks again to our three presenters. Yeah, so what's on screen now, you see this is one of the programs that we are doing at the moment. We are having the MTE 2020 Special Edition COVID-19 International Innovation Award. So if you have an innovation or an initiative which you have implemented during this pandemic, this is probably a program that you'd like to find out more about. You can go to our Malaysia Technology Expo Facebook page for all the details. Next, Henry. Right, so this is our next webinar, next Tuesday at 3 o'clock. Topic is unique challenges and experience of water operators during COVID-19 MCO. And our speaker is Encik Ishak Hasnan. He's the chairman of the Malaysian Water Engineers Action Committee. And he also works for the Perak Water Board. So I hope next week you can all come back and join us for this interesting topic. Okay, so do follow us on our Facebook page for our links to today's webinar, which is going to be streamed to YouTube, so you can watch it again anytime. And all details of our forthcoming webinars is also on our Facebook page. So thank you, everyone. Dato' Kadir, are you there? Are you still with us? Do you have anything else you want to add?
No, Dennis, no. It's been a very, very good one. I couldn't get my video on. Anyways, good one. Thank you to all the speakers. Look forward to for future talks on similar or other topics of interest to the public. Okay.
Thank you, Dato' Kadir, for joining us. Thank you, Mr. Lee, for joining us today. And all our members from MWA and non-members and friends from Indonesia, Philippines, Malaysia, and around this region. Thank you, and we will see you again next week. Don't forget, you can watch this video again on YouTube. Thank you, and see you next week. Bye-bye.
Thank you, Denise. Bye-bye.
Bye-bye, everyone.
Bye. Thank you very much.
Thank
Bye,
you.
everyone.
Bye.
Thank you. Bye.
Bye.